Here is another primality test that is similar, but essentially, if you're going to just be trying all the small primes, why not find a bunch of primes at once? So this is called the Sieve of Eratosthenes. And a sieve essentially means that you're going through a bunch of numbers and sort of weeding out the ones that are not prime. So that's what we're going to be doing. And I have a little grid drawn here that we're going to perform the sieve on as an example. So let's do that. So I'm not going to maybe write anything down, but let me just talk through it. The way it works, so let's skip 1 because as usual, we're leaving out 1. The way it works is that the first number you arrive at must be a prime because it hasn't been weeded out yet. So once you find a prime, you go and cross off all the multiples of that prime. So our prime is 2, so we're going to cross off every other number in this. We know that they are all composite because they are divisible by 2. Cool. And then we go back to the start and look at the next number that we haven't crossed off yet. This one must be prime also. So now we'll go through and cross off all the multiples of this guy. So 6 already got crossed off. 9 now gets crossed off, and so on and so forth. 18, 21, 4, 27, 30, 33, 36, 39, 42, 45, yeah, 45, and 48. Cool. So the next thing is 5. This must also be a prime. Let's go cross off all the multiples of 5. And let me just go down there, down this rightmost column, and also down the middle column. Those are the multiples of 5. And then this thing must be prime. So let's go cross off the multiples of this. They are 14, 21, 28, 35, I believe, 42, and 49. Don't think I missed anything. And if I didn't, then once again, note square root 50 is about 7, a little bit more than 7. So we've checked all the primes that are at most square root 50, and we can conclude that the rest of these are primes also. We're done checking, because these things, if they had a prime factor, we must have already seen it. So these are all the primes less than 50. And to answer a question, maybe relevant to this, but also about the previous example, why are we only checking divisibility by primes? Why are we not checking divisibility by other things like 6 or 8? And the answer is because if it was divisible by 6, then it would be divisible by 2, because 2 is a factor of 6. So by checking the primes, that is like the minimum that you need to check. If you know it's not divisible by 2, and you know it's not divisible by 3, then you automatically know it's not divisible by 6. So somehow you already checked that case.